Assalamu alaikum. Today, after learning all the different methods of integration, we're going to do miscellaneous question and we're going to select a suitable method to integrate. Okay, starting with the first question, which is 2x plus 3 upon x squared plus 3x minus 10. If you notice that the derivative of the denominator is found in the numerator. So we're going to simply, because the derivative of x squared plus 3x minus 10 is 2x plus 3, so we can simply write ln x squared plus 3x minus 10 plus c as an answer to this. Okay, the second question which we have here is which is 3x square root x cube plus 1. Okay, what we notice is that the differential of this is 3x square, which is already found here. Okay, so if we use substitution in this case, and if I say let u equals to x cube plus 1. Okay, so if u is x cube plus 1, to du by dx is going to be 3x square. If I make dx the subject, dx is going to be du upon 3x square. Okay, let's, in place of 3x square, I'm going to write 3x square only. In the denominator, I can write square root of u. In place of dx, I can copy du upon 3x square. This will cancel out and you're left with, you have to integrate 1 upon root u dot du. Okay, root u can be written as root negative half if you change into index form. Okay, now let's start with the integration process. U to the power negative half, so negative half plus half is half, divided by half, meaning multiplied by 2 upon 1 plus c. Okay, in place of u, you have to revert back to the substitution. U was x cube plus 1. I'm going to write 2 square root of x cube plus 1 plus c as my final answer to this question. Okay, moving on to the next question. The next one is although I can use integration by parts here because there are two functions being multiplied by here, but since I know that the differential of, when you differentiate e to the power x square, you will get 2x e to the power. Okay, I can write it down like this. If y is e to the power x square, dy by dx is going to be e to the power x square multiplied by 2x. That means the integration of 2x e to the power x square dot dx should be e to the power x square. Okay, now if you compare this with this, you don't have this 2 here. So if I want, I can get rid of this 2 from here. And this 2 I can multiply by half so that this is cancelled from here. So I have to write half here as well, plus c. So the answer is going to be half e to the power x square plus c. In short, if you ever see that there is the e function and the power of the e function, if you differentiate, it is written next to the e function, that means it's being multiplied by the e function. You can write it as the result of this will be e to the power x square, and there should be a 2 missing here, so you multiply it by 1 upon 2. Okay, so you can use this method and do it directly instead of using partial fractions here. Okay, moving on to the next question, which is this one. Okay, if you see here, I cannot use partial fractions right now because there's just one linear function, but I can divide them. Okay, so if I divide 2x by x plus 5, x goes 2 times into 2x plus 5, so 2x here, change the sign. 5 2 times is 10, change the sign, and now you have a negative 10 as a denominator. This can be written as, this was a proper fraction, sorry, improper fraction. You can change it into a fraction like this, 2 minus 10 upon x plus 5. Now if you're supposed to integrate this, you can write integration of 2 dot dx, you can separate them, plus integration of negative 10 upon x plus 5 dot dx. Now integration of 2 is 2x plus, I can take out the constant outside, 1 upon x plus 5 dot dx. Okay, 2x minus 10. Since we know that the integral of this is, the derivative of this is found in the numerator, so I can write it as ln x plus 5, ln x plus 5 plus c. This is the answer. The next question which I have here is ln 5x. Now with ln, especially this is a special case where although then we don't see the another function here, but you can take it as 1 and you can use integration by part here. So if I use 1 here, if I use the word late, this is the logarithmic function and this is the algebraic function. So L comes first in this, so that means this is u equals to ln fx, and v dash is equals to 1. So u dash is going to be, if you differentiate this, you will get 5x and 5 here. Okay, so this will become 1 upon x, and v, if this is v dash, you have to integrate this to get v, that is x. Okay, now we have the formula vu minus vu dash. Okay, so v is x, u is ln 5x, minus v is x and u dash is 1 upon x dot dx. Okay, so this will become x ln x minus integration of 1 would be x plus c, x ln 5x. Okay, this is the answer. So we've used integration. For ln functions, you have to use integration by parts. Okay, the next question is this one. Okay, either you use integration by parts here and take both of them as algebraic function, or if you want, you can even use substitution here. So if I take u equals to, let u equals to 2x plus 1. Okay, so u equals to 2x plus 1, u dash is going to be 2. Instead of u dash, I'm writing dx, du upon dx. Okay, if I make dx the subject, it will be du upon 2. Okay. Acha, if I make x the subject from here, this will become u minus 1 upon 2 is x. Now I'm going to substitute x by u minus 1 upon 2 and integral of u dot, in place of dx I can write du upon 2. So the constant is 2 into 2, 4, so this will go out, and you're supposed to integrate u minus 1 multiplied by u to the power half dot du. Okay, u multiplied by u to the power half is going to give you 1 plus half is 3 upon 2 minus u to the power half dot du. Okay, let's start with the integration process. U 3 upon 2 plus 1 is 5 upon 2. Okay, 5 upon 2 divided by 5 upon 2, meaning multiplied by 2 upon 5, minus half plus 1 is 3 upon 2 divided by 3 upon 2, meaning multiplied by 2 upon 3. Okay, so if you multiply both of them by 1 upon 4, which is outside, it will become 1 upon 10 u 5 upon 2 minus 2 u 2 upon 3 u 3 upon 2. U can be replaced by 2x plus 1. Plus c. This is the answer. Okay, moving on to the next one. Since we just have 3 in the numerator, we can shift this whole thing up in the numerator, and this can become 3 2x plus 1 to the power negative 5 dot dx. Since we do not have an x here, we can take it as one function and do the normal integration. When we do the normal integration, minus 5 plus 1 will become minus 4 divided by minus 4, and then you differentiate the bracket and write it in the numerator, which is 2 plus c. So it's going to be 3 minus 3 upon 8, 2x plus 1 to the power 4 plus c will be the final answer to this. Okay, the next question. This can also be done with a normal way, normal algebraic integration. I can write this as integration of 3x minus 2 to the power of half dot dx. Okay, so simple. Half plus 1 is 1, half plus 1 is 3 upon 2, divided by 3 upon 2, meaning multiplied by 2 upon 3, and then differentiate the bracket, which is 3, so write it 3 here. Okay, it becomes 2 upon 9, 3x minus 2, 3 upon 2 plus c will be the final answer to this. Okay, the next question then. Okay, the next question is this one. If we notice, the differentiation of this is 2x plus 3, which is already found up in the numerator, so you can write this as ln x square plus 3x minus 10 plus c. This will be the final answer, because we see that the differentiation of this is found in the numerator. Okay, the next one. Cos 5x sin x. Okay, so I'm using substitution here, and I'm going to take cos of 5x as x. Okay, let's see what happens. If I take cos 5x as u, okay, u equals to cos 5x, u dash is going to be 5, u dash meaning du by dx. Okay, so du by dx is 5 cos 4x, and then you have to differentiate cos of x, you get negative sin x. This is the answer. Okay, if I make dx the subject, it will be du upon 5 negative 5 cos 4x sine of x. Okay, let's substitute. This is cos 5x sine x dot dx is equal to du upon negative 5 cos 4x sine of x. Sin x and sin x is being cancelled out. Okay, let's do something else here. Instead of using cos 5x sin x, okay, if I take u is equals to cos of x, u dash is going to be minus sin x. D upon dx equals to minus sin x. So if I make dx the subject, it will be du upon minus sin x. Okay, so if I write in place of cos x, if I substitute it by u to the power 5 sin x, in place of dx I'm writing du upon negative sin x. Okay, sin x and sin x is cancelled out. You're left with minus goes outside, u5 dot du. When you start with the integration process, it will become u6 upon 6, and there's a negative sign outside, plus c. Now what was u? It was cos, so the answer is going to be minus cos 6x upon 6 plus c. This is the final answer. Okay, the next question. X sine 4x. Now you have to use integration by parts. I'm going to use integration by parts. I'm writing the word late. This is the algebra. This is trigonometry. A comes first, T comes afterwards. So this is U and this is V dash. If you want to learn how to integrate by parts, then you should watch the video on integration by parts. Okay, in short, determine what functions are there. One is algebra, one is trigonometry. Look in the word late. A comes before t, so whatever comes before is going to be taken as u, and the other one will be taken as v dash. Okay, now I'm writing it here. U is x, so u dash is going to be 1, and v dash is sine of 4x. So if you have to integrate this to get v, it will be minus cos 4x divided by 4. Okay, the formula for integration by parts is uv minus v u dash. Okay, u is x, v is minus 1 upon 4 cos 4x. I'm multiplying these two. Minus v is negative 1 upon 4 cos 4x. So I am negative into negative becomes positive 1 upon 4 cos of 4x. I've taken out the constant outside, and u dash is 1 dot dx. Okay, minus 1 upon 4x cos 4x plus 1 upon 4. Integration of cos is sine 4x divided by 4 plus c. So the answer is minus 1 upon 4x cos 4x plus 1 upon 16 sine 4x plus c. This is the final answer. Okay, just one more question to go now. This is this one. Here we can see that the differentiation of cos x is found, which is negative sin x. Sin x is already there, only negative is missing. So we can write a negative here, and as a result of this I can put a negative outside also. This will become minus 1 ln 3 plus cos x plus c, and this negative 1 can become the power ln 3 plus cos x to the power negative 1 plus c. Either you write it like this or this, both of them will be correct. So these are the different techniques which we have used. Thanks a lot for watching the video.